Hi, okay, today we're going to talk very quickly about how to draw the Rutherford Bohr diagrams for the elements. Okay, now a few things about the periodic table. Here we have a periodic table of elements. Some things you should notice right away about a periodic table of elements is, first of all, we said this middle section, most of the time you won't need this for Sec 4, so we're just going to ignore it for now, okay? The really important parts are these two parts, okay? This part and over here. Okay, we're going to look at those two sections. Now, if I take those two sections and I join them together, okay, take a look at that quickly. If I join them together, I'm going to end up with a paper that looks like this. Okay, those are the two things joined together. This is the stuff, this section is the stuff on the left, and then this section is the stuff on the right. And we said for drawing Rutherford Bohr diagrams, you only have to learn the first 20 all the way up to calcium. So I put it all together so it's a little bit bigger and easier to see. Now let's take a look. Drawing these Rutherford Bohr diagrams, when you are drawing the electrons for these elements, right, hydrogen had an atomic number of 1, so it has 1 proton in the nucleus and 1 electron. Helium had an atomic number of 2, so it has 2 protons and 2 electrons on the first shell. And the way they've organized the periodic table is they put it in rows, but whenever a shell gets full, they start a new row. Just like when you're reading text in a book, this is kind of like a sentence, and when it ends, they could carry off to another one. So lithium has an atomic number 3, and we know only 2 can fit in the first level. The third one has to be on the second level. So that is 3 electrons and 3 protons. Drawing the protons is pretty easy, so we're going to skip that from now on. And you should get comfortable doing this. So that would be 4 electrons, 2 on the first level, 2 on the second level. Now, if you carry this on, and you should practice this a lot, okay? So try and get this sheet from me. I should have put it online for you. If you do this many, many times, and you do it with nice, pretty different colors, you end up with something that looks kind of like this, okay? And what I've done is the first shell has electrons on the first level in blue, second shell has in red, third shell has green, and the last fourth shell has pink. If you do this and you practice it, you will see that at the end of the row, a new layer starts, a new orbital. So that's the first electron on the second orbital, second electron on the second orbital, third, fourth, fifth, sixth, seventh, eighth. Only 8 fit on the second orbital, so the next electron would be on the third orbital. And what you'll discover is that the way groups, the rows and columns are organized, okay, is they are organized, and what you'll notice is that the side, the rows, we call these the periods. I'll just write that in here, periods. The periods tell you how many orbitals it has. So this has, hydrogen and helium have all their electrons on the first orbital. That is orbital number 1. All these have the first orbital full with 2 electrons, and they are filling up the second orbital. This has the first and second orbital, and each one of these is filling up the third orbital, and so on. And if you look at these are in period 4. That means that they are working on building their 4th orbital. So the periods tell you the number. Let's do this quickly. Periods equals number of orbitals or shells. That's the periods. Now, if we look at this again, they are organized also into columns. And the columns, we call these groups or or families. These columns, we call them groups. These tell you the number of valence electrons. Okay? Number of valence electrons. Valence electrons, meaning the electrons on the last shell. Okay, so look at what these have in common. They all have one electron on their last shell. Hydrogen has one electron on orbital 1. Lithium has its first orbital full and has one electron on its orbital 2. Sodium has its first orbital full, second orbital full, and one electron on its third orbital, and so on. Potassium has its first 3 orbitals full and one electron on its fourth. And same thing here. These have 2 electrons on the last shell, these have 2 electrons, these have 2 electrons. And so what you'll notice is that this number tells you the number of valence electrons. Why is this useful? Well, for one thing, I can look at a periodic table and without counting the electrons like we did before, filling them up from the center outwards, I can just look at any element, and I'm going to cover the drawing, and I'm going to say, sulfur, how many electrons, like how are the electrons organized? Well, I know that its first 2 shells are full, and its third shell, because it's period 3, is getting filled, and the last shell has 6 valence electrons. So it's going to have 2 electrons on the first, 8 electrons on the second shell, and 6 electrons on the third shell. 2 electrons, 8 electrons, and 6. So by looking at the column, you know how many electrons are on the last shell, and by looking at the period, you know which shell is the last shell. I'll do one more and we'll call it a day. Let's do fluorine. Fluorine has its first shell full and its second shell is getting full because it's period 2. And on its period 2, on its second shell, it has 7 valence electrons. 2 and 2 plus 2 plus 2 and 1, that's 7. So I can just put my finger on something and know exactly what the electron configuration is. Okay, I hope this you find this helps. Ciao. Just quickly, one last thing I wanted to talk about is I can ask you, based on the periodic table, to draw the electrons. The other way that the question can be is, given the drawing, tell me what group and period this is in. And it's not too hard, but there's one tricky question that I want you to be aware of. When you look at this one, you would say, okay, it has 1, 2, 3 orbitals, so it's in period 3. Oops, period equals 3. And on its last shell, it has 2 electrons, so it's in group 2, right? Along the left to right, sort of the up-down, it's in the 3rd level, because it has 3 levels. And going sideways, it would be in group 2. This one has 2 levels, so it's in period 2, and it has 1, 2, 3, 4, 5 valence electrons, so it would be in group 5. Easy enough, right? This one, I'm going to put a little star beside and say tricky. Okay, let's look at this one. This one has 1 orbital, so it would be period 1. However, it has 2 electrons. Oh, it must be in group 2. Which element is this? Now, if you look at the periodic table, I'm going to put this over here and put it in front. Okay. This element, it has 2 electrons and it would have 2 protons. That is helium. Helium, right here. Helium is not in group 2. Group 2 would be way over here. It's not here. Why isn't it in group 2? Because helium, they've put it at the end because it has a full shell, even though it only has 2. So helium is an exception. Helium, and this is helium, and even though it only has 2 electrons, it is in group 8. This is the exception. Be careful anytime you see 2 electrons. Look for it in the periodic table, find it, and then you will see that it's in group 8. And by the way, just so you know, the group numbers that we are interested in are not these numbers, 13, 14, 15. It's in Roman numerals. Okay, those numbers tell you the group number the way you're learning them. Oops, there. Okay, I hope that helps. Be careful with helium. Take care.